we were talking about alternate sorting, and so what I had was just made a sample main program so we could work with the list directly, and made a bunch of hockey players and added a bunch of goals for the hockey players, dumped them all onto a list, and then the issue became, well, we want to sort the list. But the default sort order, according to the compare-to in hockey player, says that hockey players are sorted by their points, by their total points. Okay? And if you don't want to use the default, then you have to find some other mechanism, and the other mechanism is you tell sort, don't use the default, use this guy instead. Okay? And so that thing will be in charge of doing the comparisons. It's created on the line above by going out and essentially carving out a brand new person whose job it is to do the comparisons, and then telling the sorter, here, use that guy to do the comparisons instead. So now instead of hockey player A being compared to hockey player B by sort, you now introduce a third party into the equation, and you pass A and B to the third party and say, you make the decision however it's appropriate, and we'll do that for essentially all of the players on the list. Okay? So if you go and look at the alternate sort facility, all that it has is this implements comparator, and a comparator is somebody who has a compare method inside them that takes, in this case, 2 hockey players. So compare to is one hockey player against the other one. A comparator is, here's 2 hockey players, you do the comparison. And so the compare method inside this thing does comparison by last name and then first name. And notice that since I'm writing these all in a standard way, it's really easy to just go and say, oh, comparator by last name, first name, got it. Okay? And you don't really have to read the code. And even when you're making one, the format is essentially pretty much the same. Okay? So anyone will do to carve out another one. Okay? So if you wanted to sort by first name and then last name to be friendly, then what you would do is you would write alternate sort by first name class, and you would just flip the order of those 2 paragraphs around, and suddenly you would have somebody who can do comparisons by first name and then last name. Okay? And so this is the end run against, oh, I'm only allowed 1 comparison, how am I going to get more? Now you can have as many comparisons as you want. Okay? Now, the problem with this thing is that this entire piece of code is hockey player specific. And it's sitting out there as a separate file. And it's pretty obvious that the place it should really be is inside the hockey player class, and hockey player should actually produce one of these. Okay? So this is truly an end run. It's like, oh, the hockey player class didn't make one of these for me. I guess I have to make one myself and do the work externally. Okay? But what we can do is we can suppose that hockey player actually makes one of those things themselves, and I'm going to take this entire bit of code and I'm going to stuff it inside of the hockey player class, inside of the last brace. Okay? So now this thing, because it's inside the last brace, hopefully, probably missed one. This one actually belongs to the hockey player class, and it's enclosed within it, and that's the only way that you go find it. Okay. Well, if you enclose it, then the question becomes, how do I get access to it? You could do it publicly and get access to it yourself, or we could write a getter for this thing that actually makes one and does the new and returns the object it makes. Okay, so notice in the driver here, it's the driver that's doing the new and then passing the thing to sort. What we could do instead is just provide a getter and let the hockey player class do it. So let's do that. So it's going to be public. I'm going to send back now a comparator beastie that only works for hockey players. Now you could call it get, but I'm gonna call it by last name. You'll see why in a minute. Last name, first name. And all it does is return a new alternate sort. Object. So basically all I did was I took the new and I moved it from the main program inside of the hockey player class. So now you ask a hockey player, oh, get me one of those comparison guys who does some specific job. Okay, still with me? Okay, so now having done that, in the driver, we no longer make one of these directly, but we ask one of the hockey players to give us one. So in this case, I'm going to go ask a specific player, Roberto, dot by last name, first name, and have the hockey player give me one of those guys. Okay? And so that's really just moving the new inside and letting the hockey player go out and do the hiring for you to find the guy who's going to do the comparisons. I don't have to hire him directly anymore. Still with me? Because I'm going to change it yet again.
Why did you choose Roberto? Why couldn't you just do hockey player?
You could choose any hockey player, but at this point you have to have a hockey player to talk to in order to ask them for something. Okay? So you can't ask a generic class for something yet. Okay? But we're about to get to that. Okay, so you could choose any hockey player at this point, but the problem is now you have to make a new hockey player in order to get the hockey player to go give you the guy. It would be nice to just get the guy directly who will do the comparison. So there's one little other tiny change we're going to make to this, is we're going to go into the hockey player and we're going to put the word static on the front of it. And now it always gives me grief whenever I do this. It gives me this really strange error message. I think I have to say static on this one too for the moment. There we go. And the keyword static here just basically means, in this case, you can call this thing without having a hockey player. Okay? And having done that, you can now get back to, oh, I don't need to say this. I can just use the name of the class, which is any old hockey player would do to give me one of those things. Okay? And now this variable just sort of becomes meaningless, so I'm going to get rid of the variable and I'm going to stuff that thing in there. And that's the way you'll normally see it, is sort this thing, go to the hockey player class, get some alternate sort guy to do the sorting for you. Okay. So now we have the choice. You can make this thing inside the hockey player class if you want. So if the person who's creating the hockey player class is smart enough to go, oh, they probably want some alternate forms of comparison, let me do the sort of the standard ones that I would expect them to have, go ahead and write them, and then they would be there. But if for some reason they forget them, you can always go externally and call the getters yourself and add your own. Okay, so inside the class or outside the class, both will work. Well, not done yet. If it's inside the class, one of the differences is I don't have to use get last name here. I can just use difference is A dot last name compared to B dot last name, if you don't mind a few extra dots in there, and that's a small l. Okay, and now because it's inside the class, this is that professional courtesy rule that says, oh, we can access those variables directly. Okay, so we'll get rid of this one here also, and we'll change this one to A dot first name and that one to B dot first name. Why is that professional courtesy rule there? Because if you go and put a breakpoint on this comparison routine or put a print statement in it, it gets called an awful lot. If you've got 1,000 hockey players and you want to get them sorted by last name, it's, we'll say, n squared comparisons. So 1,000 times 1,000 is the number of times that thing will get called. It's actually a little less than that, but close enough. That's worst case. Okay? So since it gets called an awful lot, they're just trying to reduce those function calls to a minimum and have direct access to the variables to speed it up just a little bit. So that's normally the way you'll see it written. Okay? Still with me, because I'm about to make one more sneaky change to it. Okay? The next sneaky change is to look at this thing here and go, oh, the only reason I made this class name was just long enough to use it here to tie the getter with the class that's being gotten. Okay? And so if you think about this, now every time I'm writing a separate method or a separate class that's going to sort differently, I also have to supply the corresponding getter with it in order to make the thing work. Okay? And this thing literally lives only long enough to be used right down there. Okay? Nobody else is going to see it because in the driver program, all that you're doing is you're using hockey player by last name getter, and you could care less what the name of the class is inside. Okay? So this class name here becomes totally immaterial. Okay? Well, the shortcut here is to just remove the class name and return new, let me just see if I can, I'm just going to literally wipe out that code, and I'm going to put opening and closing braces there. So that now becomes the constructor for the thing. And the total little bit of weirdness here is that you need a semicolon there. Okay, and I think I got that just about right. Let's just see what it's complaining about there. One more brace. Run source format to make it look pretty. And you get something that looks like that. Okay, so that just eliminated the class from the middle there, because the thing that you're making is really a comparator object that's guaranteed to have a compare method inside it that compares two hockey players. So the class name is immaterial. We'll use the generic name comparator there. Whew. And that's what they normally look like. Okay. This thing has a name. It's known as an anonymous inner class. It's anonymous because we didn't specify a name for it, and it's a class that's written inside another class. Okay? And it's just a recognition that the name wasn't really helping us there in figuring out what the thing did, because we've still got the getter and we've still got the word comparator on it. Okay, so just to leave another sample here, suppose that you wanted to write another one that worked by first name and then last name. All that you have to do is follow this same template here, and I'm just going to reverse these. Okay, and I'm going to flip these guys around. Like so, and now I've got another comparator, and if I want to use that one, I can go into my driver, and here I would just change the name of this to by first name, last name. Okay, so once you see the pattern, they're actually really, really easy to write. They all follow the same sort of style. Okay, questions about alternate sorting? The next thing that happens with this is we put team in the way, and team becomes in charge of using these comparators and not the driver program. So for instance, if we go back to our team class, what would happen in team now, we have a point where we do a sort. If we wanted the iterator to give us by first name, last name, then we would turn around and we would change this sort to just make use of hockey players comparison. Okay. But we want to leave that one with the default, right? Because points is the appropriate thing. But sooner or later in this hockey driver, after we've listed people out by points, we might want a list of all of my players in alphabetical order. Okay, so this one would use the default iterator, but now I need an alternate way of going through all of the items to show them by last name, first name. Okay, so let's try that. Let's go into the team class and let's make another iterator. And notice now that I can only have one iterator, so I'm going to call this one iterator by last name. And I'm going to change the sort to say, let's do hockey player by last name. And in this case, we want them not reversed because we'd like them to go in standard alphabetical order. And there's another iterator. Having written another iterator, if I go back to the driver, your temptation is to say, well, I'm just going to write another for each. Unfortunately, that for each, remember, gets translated into using the standard iterator and not the special one. And there isn't really a syntax for the special one, I don't think. So I'm going to do it with the long form of iterator notation and change this to alphabetical. And in this case, I'm going to use the long form, which is I need an iterator for hockey player, and we'll call it alpha, and talk to, let's just go back here, talk to one of the people, oh, sorry, my team, and say, go get me the iterator by last name. Add the import statement, Make sure you add the right one. If you add the wrong one, by the way, all that you have to do is go back up and delete that one, and then go back down and try to add the right one, which is the utilities guy, and then use the standard sort of iterator notation, which is while alpha dot has next. Go get a hockey player from them. And then we'll print them out. In this case, I guess we can leave total points there just for fun. Like so. Save it, run that one, and let's just see what we got. So there's the first iterator that's sorted by points, starting with 3, 1, 0. And if you want them in alphabetical order by last name, there they are. Luongo, Daniel Sedin, and then Henry Sedin. Questions about that? I think in race cars I asked you to do something similar. Is it race cars or the next one? Can't remember. Sooner or later I'm going to ask you to sort by alternate comparisons, so there's an example of how you can do it either way. Wow, okay. One last thing here. Suppose that in team, rather than returning an iterator like this is a little bit weird. Wouldn't it be nicer if I could just use a for each instead to go through it rather than an iterator? Well, if the team would give me a list of all of the players that was in the right order, then I could use an iterator to go through the list with a standard for each. Okay? So the alternative here is to do something like return a list. List of hockey players by last name. Hope I haven't used that name. Okay, so somebody says, oh, get me a list of the hockey players. This is going to be a copy of the list. So what do you need there? Make a new list first. So list of hockey players, new list is new array list that can only contain hockey players. Call the constructor. So there's my list, and right away, because I'm returning something, I'm going to just say, oh, return the new empty list. And now I get to figure out how to make one. What's the easiest way to copy a list?
Find one that's already there and
Highlight it.
copy and paste.
The long way is to run a for each and go through everything in the old list and dump it into the new list. The shortcut for doing that is to mention the name of the list, the other list right here, and let the constructor do the work for you. So there's an alternate constructor that will just do the copying of the list for you. Okay? And the reason for that is that That's one thing we do almost all the time. Make me a copy of your address book so I can go throw some people out of it, you know, and then add it to my address book, and then throw away the copy that I made in between. Okay, so since we do that all the time, there's the little shortcut. So now the only thing is that they wanted this thing sorted, so we'll do collections.sort of my new list, and I need something out of hockey player that will do the sorting for me. And there's the joy of my naming convention, right? As soon as I type hockey player dot, it shows me what sort of comparisons I can do. And, oh, okay, we wanted this one, by last name. Keep the names the same. So there's sorted by last name. Okay. So given that, in the driver, what you can do rather than doing that long way is you could turn around and you could say, let's just do another way here, alphabetical by list. And what we'd do is we'd talk to my team and we'd say, wherever the get is, what did I call it now? Have to go look.
Get players by last name.
Get players by last name. There we go. Get players by last name. The thing that it's going to give me back is a list of only hockey players. And given that I've now got a list, click on the bulb, do the import. I could now run a for each for hockey player who in the list, and then print out their information that way instead. Well, gee, I wonder if I could, instead of putting that variable there, just take that word there and put it into there. And then I wouldn't need that at all. Okay, so the fact that it returns a list means that you can now use it in a for each, and off you go. Okay, so this one ends up being an interesting idea, but it's a little bit annoying to have to do because you have to specify the iterator in order to make it work. In this one, if you get the list to return an iterator, or you return a list, then the list has an iterator by default, and it will just magically work. Okay, so there's a bunch of different ways to manipulate lists and sort them. So you now have got equals and array list index of for finding things matched up. You've got sort and compare to by default sort order. And if you need some other sort order, you can add extra comparators to your class and do it by any sort order you want. And if the class doesn't provide it, then you can write an external comparator and you can choose whatever fields you think are appropriate and pass that to sort and do your own order. So all of those features are now available to you. All in one tidy example. Okay, last call for questions on sorting and searching. The reason I wanted to give this to you is we're going to go back to taking you fishing, and we're going to do in a bigger example that hopefully uses all of the stuff we've learned so far all rolled up into one to do something surprisingly useful. Okay. Okay, well, let's go fishing then. Going to make a brand new Java project for a brand new idea. If I can ever get there. Okay, you remember the fishing example? We're going to do the soup fishing derby, and we said we were going to send a bunch of fishermen out to catch fish, and they were going to come back and give their fish to the registration desk, and we were going to put them in all sorts of buckets, and off we go. Okay? So now we have to turn this into a Java application. Other than the front-end GUI, this is going to be essentially all of the code that you would need to manage the fishing derby. So here's the first problem. When you start out writing code, there's sort of two approaches that you'll see. The first approach is you start at the highest level and work your way down. So the top-down approach, start out with the biggest thing and work your way towards the smallest thing. The other approach that you'll see is people will work from the smallest thing to the largest thing. So they'll do what's called bottom-up development to build things. In truth, neither of those works very well, because they all suffer from getting to the middle and going, I've really started to lose track of what's going on. Okay? So the easiest way to build things is actually to start from both ends at once. You have a pretty good idea of how it's supposed to work from the top end. You have a pretty good idea of what the small things are supposed to look like because they're small, and you sort of start out either end and build towards the middle. And whenever you run into a problem with one, you switch to the other side of things, and you keep attacking both ends until you somehow get to the middle. Okay? And that tends to be the easiest approach to building these things. Okay? And this thing is only going to be a few levels deep, and we'll see already that it just makes our lives a little bit easier to be able to do it that way. So, fishing derby. Where do you want to start? Front of the thing or smallest thing?
Smallest first.
Smallest first, sure. What's the smallest thing in a fishing derby? A fish. Okay, so let's make a fish. There's the fish class. What sort of information do you want to keep about a fish for the derby? Size is important, so that's private. Int, size meaning derbies are by weight. Okay, at the very least. Any other kind of information? You could keep the length.
Who catches it?
Could keep not who catches it, because that's not something the fish cares about.
Kind of fish?
Yeah, keep track of the kind of fish, sure. The type of fish. Okay, there's no magic to this. It's like you can say, well, okay, we could get by with just weight, and we could say that's the only thing that matters in this fishing derby. If you're looking ahead, you're going, oh, okay, maybe it's nice to know what kind of fish it was, and eventually maybe it makes sense that we separate out the derby into who caught the biggest salmon versus who caught the biggest tuna, so that's not bad. You could separate it, you could add length, and you could say, well, okay, maybe we should measure the length of the fish, and we could give an award for who caught the longest fish, and we could give a bozo award to who caught the smallest fish. There's lots of things that you could do there. So no big deal here. Just pick something that works. We can always go fix it later. Okay. Well, if those are the two data fields, then we know that public constructor for fish is going to have an int weight and a string for the type coming in. And now you know this is getting boring. And we'll need some getters for that. get weight. Okay. By the way, notice I'm not really all that interested in what kind of measuring unit is used for weight. Doesn't really matter to me whether it's grams or ounces or whatever the units happen to be. And so quite often the easiest way to write it is to avoid even thinking about units and just go, it's just some arbitrary weight for now. Okay, so there's our fish. Notice the other thing is I'm not going to bother writing all of the fish class. I'm just going to start out and bump off the easy stuff, and eventually if I discover that I need some extra functionality in the fish, I'll go in and add it later. Okay? So for now that's probably good. Fish probably isn't going to change much. It's not like somebody's going to come back and say, okay, it actually weighs more or less. The fish just should be what it is. Okay? Next class that you want to write.
Fisherman?
A fisher person, okay. You can think of it as being the fisher person. You can also think of it as being the bucket. And I'm gonna say that we should probably just think of this as the bucket, because it's really going to be a place to store fish, and it's going to happen to have somebody's name on it. Okay. So sure, bucket. What sort of information do you want to keep about the bucket?
Owner?
That's going to be owner, which is really first name and last name. And I'm doing that just to make you have two fields so that we can have something to sort. Okay. Another, by the way, is that in most of these things that you write in these sorts of languages, you always split up the fields. So it's bad news typically to make a string that has both first name and last name in it and try to pass that around, because then you always have to break it up or put it together. And so the typical rule is break everything up, and then you've got the pieces that you need, and if somebody needs both first name and last name for the GUI, they can go get it, okay, without having to do much work. So a bucket has a first name and last name, so I would make a bucket so there's a bucket. And we'll save that information. I should really learn to use control space more since I'm such a bad typist. And I guess we should have public string get first name and public string get last name. Anything else the bucket has?
Contents?
A bunch of fish, right? So private list that can only contain fish, all fish.
These?
Yeah, I was doing the Nordic thing. Okay, make sure you get the right import there, and we have to initialize that variable, which is what people typically forget. So that's a new array list that can only hold fish. Call the constructor and hit the bulb. How are you going to retrieve the fish? If somebody wants to go look at all of the fish in that fisher person's bucket.
Iterator?
Two ways to retrieve it. One way is to use an iterator. So just send out the array list iterator, and then people can run for each on your bucket. The other way would be to do what? return a copy of the list, and another way would be to
Search the list. Comparator.
get I want all of them.
Well,
The other way is positional notation, right? So provide a get me the nth item thing, so a get routine, but then you have to add a size routine so that people know when to stop. Okay, so those are more or less the three ways. For now, we'll wait until we actually have to go retrieve fish. We might not never need to see them all. We might only need to see the biggest one, who knows? We'll see what our application does. So I'm not even going to write that for now. I'm just going to say, well, okay, maybe that's enough for a bucket. Okay. Next class. The Derby. So we have a Derby class. What information does the fishing derby keep? Think of this as the registration desk. The name of the derby, so private string, the name of the derby, and what else?
competitors.
The list of all of the competitors, which in this case are represented by their buckets. Okay, so we'll do the constructor for that. That only takes the name, and we'll set the name equal to whatever we're given to remember it, and we'll initialize all buckets to be an array list that can only hold buckets in this case, and do the import statements there. And we'll do public string get name, so that at the very least we can find out the name of the derby. And there's the third class. So really the classes, the easiest way to find the classes is to just think of what are the things I have. So these are all nouns in English, right? So anything that's a thing is something that you just automatically turn into a class and record some sort of information about it. What other class do we need? We're missing one, the highest level.
Driver.
You need a driver class at some point so that you can actually run this thing out. So this is a fish driver. It's going to have a main in it. And this is the one that's the let's pretend. Suppose that we're starting out and it's first thing in the morning. What's the first thing that happens? Before people register, start a new derby. Somebody's got to come out and set up the registration sign, so they've got to make a new derby object to start this thing. And the driver program needs to remember that into a derby object. Okay. By the way, I would have written this thing first. I would have written fish, and then I would have written derby, and then I would have decided I needed buckets in between, but either way works. We wrote it essentially bottom up. Okay. So somebody planted the sign, and now it's time to start registration process. So how do people register?
And you a bucket. And tell.
Who are they going to talk to? They're going to talk to the registration, so why don't I just change this name, if that's what we're thinking of it. We'll call it what we think it is. So now somebody's going to walk up to the registration desk, and they're going to say what? I want to register for the Derby. What information are they going to provide when they register?
Yeah, first name, last name.
Okay.
And their bucket.
Okay. There's two choices here. Remember, we said when somebody walks up, they can do this. They can say, my name is Fred Flintstone. And I want to register for the Derby. And that'll work, but who's going to supply the bucket? The presumption here is that the registration desk is going to somehow go put the name onto a bucket that they've already got. So the other alternative is to make the new bucket up here so there's a bucket for Fred Flintstone, and then we'll turn around and we'll register Fred, which means really accept his bucket. So this is really Fred's bucket. Okay? Remember I said that Java tends to not like to take bits and pieces of things. So right away we're turning those two bits and pieces of strings into a bucket and then sending in the bucket so that people can just work with the bucket. Okay, without having to worry about working with the strings. And really all it amounts to is who does the new, right? Do I do the new here, or do I do the new in the registration process? Somebody has to buy the bucket. So in this case, I'm sort of saying Fred's going to buy the bucket and they're going to bring the bucket. Okay, so we'll just do one quick little change here. So we've got register, public void register in the Derby class, and now someone supplies a bucket to us that could be anybody's bucket. What does the registration desk do when they get the bucket?
Take it off their hands, label it.
Put it behind the list, or put it behind the registration desk, which means in this case, get the list class to remember, oh, there's one more bucket. And so that's literally putting the bucket behind the registrations desk someplace in all of the list of buckets that you've already got. Okay, and that's a good place to stop for today. Tomorrow we'll continue to enhance Mr. Derby.